So today I'm going to talk about quantum number. Now what is quantum number and what does it tell? Actually, the address of an electron, right, can be known by quantum number. Right, the address of an electron can be known by quantum number, or we can say that the address of an electron can be determined by 4 steps, right? So we can, if we want to find out the location of someone, as we can consider that, for example, this is country, right? Then this is province, city, and the last one is town. Like that, we can identify that this is used to that. If you want to find out the location of someone, we can follow this pattern. And like that, we can also follow the same pattern to find out the location of an electron in an atom. For example, there are 4 steps, or we can say there are 4 quantum numbers. Let's go with the first. The first is principal quantum number. Principal quantum. It is usually represented by n. Second one is azimuthal quantum number. Azimuthal quantum, actually it has 3 names, right? So subsidiary, and one more, angular momentum. It is usually represented by a letter L. Then we have the third one, that is magnetic, or we can say that orientation quantum number, and it is represented by M, right? This, it tells about shells, it tells about subshells, it tells about orbitals, and last but not the least, which is spin quantum number. Okay, it is represented by S, and it tells about the direction or rotation, right? For example, the first that we're going to find out is shell. Okay, can be considered as shell. Then this is subshell, orbitals, and the spin motion, right? Then we're going to find out subshells, right? Second, last, in addition, orbitals, and last but not least, that is spin or direction, right? So we can move to the first quantum number, which is principal quantum. Okay, we're going to start it from the basics so that everything would be clear. What does principal quantum number tell us? Actually, it gives information about energy levels, orbits, and shells. Now what are they? What are these orbit, shells? Actually, these 3 are the name of the single these 3 are same, right? So we can consider that this is nucleus, right? This is 1 shell, 2nd shell, 3rd shell, 4th shell. This is known as shell or energy level or orbit. It can have 3 names, right? So this is 1 first shell, this is 2nd, this is 3rd, and this is 1, and it is designated by K, L, M, and N. The principal quantum number tells us about 2 things. Radius. The formula is we can say that a 0.529 multiplied by Armstrong multiplied by n square, and if we are concerned with the atomic radius of other element rather than hydrogen, so we can include z square as well. This is atomic number, right? So actually this A represent a value of the values of constant. constant. Actually, the formula of radius that is given is, which is epsilon n square h square pi z square m, where epsilon h square pi z square m is a pi m is a constant and is represented by 0. This is Armstrong. This is also known as Bohr constant, right? This is Armstrong. Okay, and these are the variable, which is n square and z square. It varies with atomic number and from element to element or atom to atom, right? It tells us about two things. First is radius and second one is energy. In the formula of energy, minus 2.18 multiplied by 10 to the power, I think it's 10 to the power minus 18 multiplied by 1 upon n square. This is the basic formula. We can say that minus 1313.31 multiplied by 1 upon n square kilojoule per mole. We can have three formula for it, right?